Good morning, everyone. I hope you all are energized for the third day of the conference. It's my pleasure to welcome you all here for the final day. We already had two incredible days filled with inspiring discussions, thought provoking sessions. If anyone is interested, there is also a parallel session running in Hall A, which is about learning from clinical and cohort studies. Today, whole day, Hall A sessions will be running, and in Hall B, also two workshops are there from deep holistics and women's health. So, without any delay, I'll dive into today's first session, which is about data science for longevity. We have got some fantastic presentations lined up that will continue to build on the ideas and insights we have explored so far in the field of aging. Without further ado, I would like to introduce chair of the session, Professor Chiranjeev Bhattacharya, longevity investigator, Department of Computer Science and Automation, Indian Institute of Science. Over to you, sir.
So thanks for the introduction. So good morning to all of you. So we have 5 talks today, and these are 5 different perspectives, I would say, on how data science is impacting longevity. And now in this day, we are supposed to live in the era of AI. Now, one of the key things, as many of you know, to AI to succeed, we need data. And this is, I think, more foundational, and hopefully we'll take back lots of good insights from this talks. So may I invite Mr. Prashanth Prakash to give a keynote talk. He's obviously needs no introduction to, at least in this campus and across the country and even globally. He's a well-known entrepreneur and philanthropist. He's a founding member of Accel India. He's won the Padma Shri Award in 2025 from the Government of India. Most importantly, it is his vision and support which has made Longevity India initiative possible. So he is our most loved patron. So Mr. Prashanth Prakash, may I welcome you on the stage?
I don't think there is as many areas that venture capitalists and academicians, everybody is excited as the applications of AI in health and medicine 4.0 specifically. So I thought, one is that, of course, I could do a little bit of a high-level talk, but I thought I'll also have with me today Ram, who works with me with my AI team on actually implementing some of the novel and current LLMs and beyond for Medicine 4.0. So Ram is a practitioner. He has now a data science and AI team dedicated specifically for healthcare and AI. So I think you'll get a lot of under the hood insights from this discussion with Ram. So I thought let me do it as a fireside chat with Ram.
Welcome the other speakers.
Yeah. So Ram, it's early in the morning. We got to wake them up, right? So it's I think this is
Let's try
a
that.
big enough topic that we should be able to get everybody excited.
Good.
Right. So Ram, there's this aspect of healthcare and AI where it's really high stakes at one level. I don't think there's anything more higher stakes than life and death. Right. So it's a very intense area in that way. And also there's this issue of explainability and provenance. You need traceability because there's litigation. So very interesting area. So maybe at some high level thoughts from your side on the challenges at a very high level of AI and healthcare.
Yeah, so the first thing is, I think that a lot of challenges come in because we equate AI to LLMs.
Yeah.
That's not really true. I think many of these challenges can be addressed, if we incorporate a lot of classical AI/ML methods, combine that with knowledge-based systems, and use the power of LLMs, right? So as you said, explainability, and being able to control the output of AI. Okay, all these things are extremely important in this area. And LLMs, it's very hard to get them, uh, to adhere to how we would like to control all these things. So challenges here again, the nature of data itself is multimodal,
Yeah.
and it's not always text based, right? So we need a multitude of systems to solve this problem, not just that all fall under AI, but not AI is not equal to LLM. So
Yeah, so we had, of course, a lot of leverage of AI to some extent, pre-LLM era. Maybe just for the audience, a little bit of a quick recap on applications, the classical reasoning models and some of the machine learning applications in healthcare prior to the LLM world.
right, I think deep learning definitely made a big impact, and uh, being able to read medical images and then coming up with inferences on
Yeah,
that.
mostly for things like teleradiology and some of
Yeah,
these.
so those things are, that is definitely the more recent time. But for me, the most inspiring thing is what was done in 1976, right? The mycene,
Mycin, yeah.
right? So it's a rule based system. And if we read the design principles behind mycene, we see like all the things.
Mycin is probably so old that a lot of some of the people in this audience were not born when Mycin.
Even I wasn't born.
Yeah. But I think it gives you a perspective how old AI is. My first thesis, master's thesis, was in expert systems for disease management in AI, and this was in the late 80s. So that's how old the
Right.
first wave of
Yeah,
AI.
this, and it's really a brilliant design. No, if you see mycene, it's a rule based one, but they had thought through the explainability and all those things, interpretability of the inferences that are drawn. Okay, and most importantly, human in the loop. The importance of expert in the loop to guide the AI system to arrive at the inferences. I think we have to take a lot of lessons from that system and then see how the modern AI can enable us to rethink that system, because coming up with those rules, doing the knowledge engineering for such a system was very hard,
Yeah,
right?
so what's that process today? So you have LLMs, which are great in reasoning for textual uh, uh, languages and so on. And then you have the next generation of LLMs with the O1 and reasoning capabilities. Of course, there's the big DeepSeek type of distillation models. Uh, so with that, I mean, I still feel that's not good enough, right, for most AI, most health AI applications. It's not only because of the multimodal aspects, but beyond that, there is a lot that we are working on.
Yeah.
What do we need to do which is fundamentally different and from a building blocks level different for applications of AI in health?
Yeah. So if you look at reasoning models, right, the O1 or DeepSeek, the basic idea is to use uh, LLM as reinforcement learning agents to be able to generate reasoning tokens autonomously. Okay. So the question is, do we really need autonomous chain of thoughts and reasoning in our scenario, right?
Yeah.
So if we are able to build a good a knowledge base of the medical knowledge as well as the practices and all that, you can use the verbal reasoning capabilities of LLMs if needed, and then combination of these two will give us much better advantage, right? So one reason is the all these reasoning models and LLMs have to be pre-trained with a lot of data, and the knowledge itself is pretty dynamic and then continuously evolving in this space. Now which part of the knowledge is used in reasoning, we will not be able to explicitly control with the reasoning models.
Right.
But if the explicit knowledge representation we will be able to control that part.
So this idea of explicit knowledge representation and creating ontologies and in being able to build up that knowledge from experts, we have found that to be a big challenge, right? Because getting eliciting knowledge. So one of the things that we are trying is how do you use AI to elicit knowledge from
Right.
experts? Maybe you want to talk about that.
Yeah, so obviously eliciting knowledge and then bringing that into a formal representation so that classical reasoning models can be reasoning algorithms can be used is hard, right? So now the way we are trying to address that is create a knowledge engineer assistant itself.
Yeah, it's I mean, the more popular agent for knowledge.
Agentic form of it, yeah. So there are lots of interesting things that we can do here. One is to use the reasoning models to kind of you know uh, generate knowledge and then get verified by the experts, and
Yes.
then that is one way to scale that.
Which is, I think, a good starting point for most.
Correct, correct. And then second thing is to be able to extract this knowledge from the research journals and those papers and all, right? So there again, just ingesting these research papers into LLMs will not work.
Yeah, in fact, we had a lot of challenges just getting the numerical formats harmonized across lab reports. And I mean, it's easy to kind of ingest multimodal data at a very high level, but normalizing and getting that, I mean, that was a big challenge, right?
Right, right. So there again, even parsing itself is a big challenge, right?
Even parsing was, yeah,
Because like LLM based parsings, the multimodal parsing, these things also don't work in a reliable manner, and it's very sensitive thing, right? So we can't read some number wrong and then feed it into the system.
right.
So there are a lot of guardrails that need to be built around that itself.
Right. So yeah, that was something we underestimated. So when we started building these systems, just getting these multitude of lab reports and these tables from these journals for read and ingested was a big challenge.
Journals will also have another level of challenge, right? There is a, like, it's a continuously evolving knowledge. So there may be contradictions, there may be then updates to the previous work, there are interconnections between these papers, so they cannot be treated like independent sources of text to train the LLMs.
Right.
So there is a need for connecting these pieces of knowledge across the papers and then use that structure to train the model as well as to represent the knowledge itself.
So one recent development was this big 100 million funding for this company called One Evidence, which was trained on the New England Journal literature.
Yeah.
What do you think will be the limitation? I mean, and it was meant not as a decision support system for a doctor. I think they caveat that very well. It's more meant to be like a reference for a doctor.
Right.
But it's still like a $1 billion valuation for a company that just started day one. I mean, just shows the value of how people ascribe to just an like it's just a context specific LLM, right? There's nothing beyond. But what's the limitation of something like One Evidence?
So it depends on, like, what is the application. If you are using it as a search system to quickly access the knowledge across these journals, definitely that is useful,
Yeah, yeah,
right? So beyond that, if you are a service providing healthcare, then somebody needs to own the decisions that are derived out of those things,
right.
right? So that is where we need to build layers and layers of control and explainability and all that provenance.
So the one approach we are working on is this idea that you use LLMs to also generate hypotheses, right? And then work with the expert to kind of narrow down on one or two hypotheses, and then go from there.
Yeah.
Maybe you want to talk about that approach.
Yeah, so the most of our reasoning is done like a rule based system, but implemented using the modern LLM capabilities, right? So that way, it gives us two key advantages. We know we will be able to exactly trace the reasoning that is used in the inference.
Yeah, because this traceability of reasoning is extremely important, right?
Yeah.
Because you want to know what was the chain of thought that was used.
Yeah, so that is also, we need to be able to, knowledge is going to be, is not going to be complete, right? So we should be able to find those gaps in the knowledge while doing the inferencing itself. So that has to be part of the system.
How is that this whole finding gaps in the knowledge, right? How are we say hallucination is one different issue. I think largely we are kind of coming to grips to that. But beyond hallucination, these gaps in knowledge, how are we addressing that?
See, because we are using formal reasoning systems, like we will be able to know when we are not able to connect the dots, right? So if we are not able to connect the dots, or if the the hypothesis is, we are not able to make a progress because we don't find the appropriate next step to take. Okay, so that is one way. That is where we don't want to stop there. We want to get the expert involved there, and then provide them that knowledge assistance in place,
Right.
so they can continue with the reasoning and inferencing part of it, but that will go in as something that should update the knowledge base for us, right?
Correct.
It has to be a kind of continuously evolving system. Pretty much you should start with no knowledge, and you should be able to keep building this over a period of time with expert validating everything that goes into our knowledge system.
I think we went like slightly little bit deep into the weeds on reasoning, and we'll probably bubble up a little bit on the applications and where we are seeing applications. So one application that we are seeing is in Medicine 4.0. It's really important to understand the user. And I think today it takes 30 minutes of consultations or 45 minutes. How can you compress that time to understand what a primary physician or a functional medicine person would have gotten from the client, but use AI to do that smarter in 10, what would have taken 30 to 40 minutes? Can you use AI which just based on the chain of thought, kind of optimizes the information elicitation process?
Right. So that's a good use case for conversational agents. But conversational agents that can use the knowledge and processes that experts follow,
Yeah.
and then implement that as a plan to do the survey or the interview will be.
Yeah, and here the interesting thing is that you can do it at your convenience. There's flexibility, so you have like a
You can pause and continue, right?
yeah.
Like, so you
I mean,
can
nothing stops, so you
give
can
the context.
the context is retained.
Yeah.
So this also leads me to another challenge that we are finding, this whole idea of memory, right? So LLMs don't have memory. So how do we, in our modeling of these systems, because we want longitudinal data of our clients over time, how are we implementing this idea of memory?
See, we have a custom ontology, and we keep the client data as knowledge graph, right? So from this, our goal is to, for any task that we want to perform, to pull in the right knowledge, right context, set it up on demand, and
Right.
then get the LLM to respond to that.
So there is a way to kind of, uh, rejog the memory and get.
Yeah, yeah. It's so the memory itself is like, I mean, it's a high level thing, right? LLMs just whatever text you provide, that
Yeah.
is the prompt, and the next token generation, that's what happens. So what we put in that context is up to us, so we can control significantly.
So the next big application we are saying is in explainability, right? So once you have gone through these diagnostics, once you've gotten your consultation done, you have this option now with being able to, at your own convenience, have the power of otherwise what you would have to call your doctor, I mean, get more clarifications. So this ability to interrogate your own data is another application that we are.
Right. So that's interpreting own data also, like, there is, it's not everything is verbal data, right? So it's
Yes.
reports and all that. So we need to understand the connections between the multiple reports and the parameters, and then set up the context in a verbal form so that we can rely on LLM's ability to interpret
Yeah,
those.
because unless you set it up for the LLMs,
Yep.
the LLMs can make some inferences that are not medically sound or not.
Yeah. So there is always a tendency for LLM to rely on its parametric knowledge to respond to questions, right? So we do a lot of things to control that, and because when a response is given to explain something to the consumer, we have to make sure that the information comes actually from what our clinicians, experts have validated.
Right.
It cannot be generically responded.
Sure. So I think maybe let's get to questions, but I think you would have understood that I'll just summarize. Number one, LLMs standalone won't work for Medicine 4.0. You need a lot of there's a lot of dependence on other elements which we have spoken about today to make LLMs work in this case. And there also needs to be a tight control of what, even if you're using LLMs, uh, you need to make sure that the way LLMs are used are very well bounded. We also looked at multiple applications in the entire life cycle of Medicine 4.0, all the way from understanding the client to then the client having the power to understand and rely on their data. And we didn't speak about one aspect, which is human behavior, right? So one of the big things that AI will let you do, we didn't have the chance to talk about it, but nudges and being able to uh, get you to do the right thing from a lifestyle perspective is very, very powerful. And I think AI will play. So it's almost like Medicine 4.0 can't exist without AI. And I think that's the big opportunity now, that because AI is real, I think Medicine 4.0 will be real. That's kind of the high level summary. Quick 2, 3 questions.
Couple of questions maybe.
There's one there on top.
So maybe
Maybe anything. There's one here earlier. Yeah. No, you can. Yeah.
Uh, so very interesting. So one thing I was interested in, I think the most interesting part is where these models can basically come up with a hypothesis, and then go and try and connect the dots,
Yes.
and then find the I mean see whether it's true or not. I think that's brilliant. But my question is especially when you look at research data, quite often you have two or more, multiple papers, most of which contradict each other. Okay.
Yes.
In these cases, how does this going to handle it? So I'm from Project Serotonin, but yeah. Thanks.
Yeah.
So there are a couple of things, right? That's what I said. When we represent the knowledge, we have to semantically understand those contradictions and then represent the knowledge. That's one part. Second thing is, we are building a system that is expert in the loop. So whenever these contradictions are there, so that will be presented to the expert, and they can help the AI to navigate through this.
Yeah. I think there'll be a long period where the dependence on the expert is going to be significant. Yeah.
Hi, very good morning.
Yeah.
A very interesting discussion. So, just a quick question that I'm sure we'll find solutions through AI and data science and application in Medicine 4.0. But from a user's perspective, for them, isn't it very confusing eventually what to go to, which company to rely on, whether it's the validity of the data or the scientific validation? So, is there enough room for at least multiple companies? I'm sure there's no dearth of companies here in India as well as in the US working on this.
No, see, I think unlike the open platforms like OpenAI and Anthropic and so on, I would say these domain specific models will become proprietary to companies that own the customer data, because it's really a combination of the expert knowledge that you elicit and then the training that you then on top of that, do in various forms, and the refinement, the knowledge refinement that happens post that, post training. I think that is high IP. So I think it will be proprietary. So the horizontal LLMs will be all open, but I think these will be proprietary, because also there is a level of monetization. It takes time and cost to train these models. So these companies would like to monetize that.
And very interesting and exciting. I just want to ask again, how do you see equating it? Is it going to be like trickling down, or is it? I have no idea. Just because we didn't talk about it, so what do you think?
See, there is, like I said, there is a cost to building these models and making these models robust. And there is incremental cost to keeping them updated. But my sense is that once this knowledge is built and this is robust enough, I think the cost of deployment is not going to be too much. So the companies that have this have the option of making that a bit more democratically available. So yes, it is possible. It depends on how the company wants to do that. But the company is not going to incur a lot more. It's not like I've built something and I need like 10,000 more people to deploy it for the rest of the country. Thank you. Thank you so much. And I hope you found this interesting.
Thank you.
The speaker.